Good afternoon, my fabulous chemistry students. Video number 9, ground state versus excited state. Woohoo! Last video of the unit. And guess what? It is going to be long, but this is the funnest part of all of this stuff because we get to see all these pretty little colors. You know what I mean? So, we will be able to distinguish between ground state and excited state, and we can get into our electron configurations that represent that. So that's basically what we're going to do here. So what's happening here is basically electrons are cruising around and cruising around. Wait, let's let you read this. They're cruising around. And if I give them just the right amount of energy, that would be from here to here. They can jump either down or up. And then so here's a good one. I can excite an electron up, and then he is going to fall back down. And when he falls back down specifically, he's going to release light in the amount of energy that he had given. So here's a quick excited versus ground pictogram, if you will. Neon has 8 valence electrons and 2 kernel electrons for 10 total. And so I have 2 in the first shell and 8 in the second shell. Well, if I give one of these electrons that was here enough energy, up he goes to here, and now I am excited. And you'll find that it is just for a nanosecond or two. So ground state electrons are in their lowest energy state, and we will find that on the periodic table. Okay, so for Li it is 2, 1 if we look that up. In the excited state, electrons are found in a higher energy configuration, so any configuration basically that's not on the periodic table. So 1, 2 will go to 1, 1, 1. You'll notice you will not find this on the periodic table, but you won't find this either because it should be 2-1. That's what we find. So I could do this or I could do this. These are both excited versions of the original, which is 2-1. The original would be the ground state. The other options are both options for what we call the excited state. What the notes don't say is, though, here is 3 total electrons, here is 3 total electrons, here is 3 total electrons. There must be a given, or the same number of our given electrons in order for it to be what we call excited. Remember, if I add an electron or take an electron, I've made an ion, and we did that a bunch of videos ago. So what you need to remember is that the number has to equal. Can't add or lose electrons. What I do is I just move them. So let's play a little bit. 2-1, lithium. I see it on the periodic table, ground. 2, 0, 1. I do not see a 0 before a 1 on any electron configuration. But you're going to say to me, Mr. Milks, listen, do I have to look at every element every time? There is kind of a trick. So here, let me show you. Normally, I'm going to have 2, 8, because 8 is what fills everything after the first one. 8, 8. All right? So if I have something that is not full, like 2, 7, 8, this would be 8 before this got to 7, right? Because I'm going to fill here, then here, then here. We learned that in our Bohr diagram. So we start at 2 and work our way out. So this should be 2, 1, and it's not, because the electron that was here jumped up to this third. So that's what makes it excited. 1, 1, 1. We learned from our last page that that is an excited version of this because there's 3 electrons. So that is, not ground, excited. That's right. And then so 2, 7, 3. Well, this number should be 8 before this goes to 3, correct? So there was 1 here and it jumped up. So that is excited. 2, 8, 2. Okay, this is full, then this isn't. That's okay. The valence doesn't need to be full. That's ground. Okay, because I filled it up. 2, 8, 8, 2. That's full. I'm good. Ground. Now, when I start getting into these numbers here, 18, this is how I fill in the middle group of the periodic table. We will learn that those are called the transition elements. But 18 is full here for transition. We see that 17 is not full, so one of them must have jumped up. This should be 2, 8, 18, 5. Notice then the 18 is full before I start putting them in the valence shell. So this is excited. Let's see you guys do the last 3 before we come to class and see how you do. We unfortunately have a lot of notes to take. So the greater the distance from the nucleus, the greater amount of the electrons have. The energy, when ground state electrons in their normal configuration absorb energy, they go up to a higher energy level, or what we call an excited state. This is very unstable and doesn't happen for very long. Okay, so the excited electrons, after like a nanosecond, fall right back down or drop back down to their lower energy level. This is when all the fun happens. Now the amount of energy in to excite it is going to equal the amount of energy lost when it drops back down, if that's the electron. And what happens is I give off light. And light is fun. And light is a wavelength. And light has a specific wavelength if it has a color, and these colors can tell us the wavelength. The wavelength can tell us the amount of energy. The amount of energy can tell me how far did it jump if I know how much energy I gave it, and I can do a lot of fun things with atoms. So, ground to excited, energy is absorbed, okay? This is what's called the dark line spectrum. On the first page, it was the dark one on the bottom is produced, okay? When I go from excited to ground, though, that's when energy is released. And this is what's called our bright line spectrum. And this is what I can use to distinguish one element from another. This is what I can use to distinguish what elements are in a star, if you will. Because the light comes in and I can test its wavelength and I can tell what atoms are in that star based on what light they're giving off. So here's the dark line spectrum down here. I lied. Here's the dark line spectrum up here and the bright line spectrum here. So dark line spectrum is absorbed, bright line spectrum is emitted, and this is, notice, see how the lines are bright? That's why we call it the bright line spectrum. Here the lines are dark against the spectrum itself. So this is how we figure some of these electrons things out. What we've come up with was Mr. Balmer. The electrons falling from an excited state down to the second energy level give off visible light known as the bright line spectrum or visible light spectrum, right? Roy G. Biv, the rainbow. Different elements are going to produce a different light spectra. The spectra is unique, so it's going to work like a fingerprint, okay? And I can use that to identify the different elements. So practice, which of these following are ground versus excited? So wait, no, it says which one is ground. Okay, so which one's full all the way to the valence? 2 not full with valence, 2 not full with valence, 2 not full valence, 2 8 1. This one is full with valence, so this is ground state. So now excited, basically, so they're all going to be full except for one, right? Full with a valence, full with a valence, full, not full with a valence. There we go. Give one possible example of an excited state for oxygen. Oxygen is 2 6. So remember, when I do this, the key is I have to still have 8 total electrons, or I've created an ion of some sort, be it a cation or anion. So I could go 2 5 1. Just kick one up. That's the easiest way, right? So 2 5 1. I could do 2 4 2. That would count. I could kick 2 of them up. I could kick one from here and go 1 6 1. Kick the 1 all the way up. I can do all sorts of things as long as I end up with 8, and then I'm pretty much happy. Will they normally happen that way? No, but I could. So we have a few more questions for you guys to answer. We will check the names of this, check the answers in class. I don't want to waste time in this video too much because we're already at like 9 minutes, Mr. Mokes. This is dragging on and on. This one's good though. So here we have an unknown mixture here. This is going to be just like the lab. So here I have gas A, B, C, and D. Look, I have a line here and I have a line here. I have a line here and a line here. So I definitely have A, right? And there's, yep, so that's all A. And then here I have D and D. So I have A and D in my unknown mixture. See how that works? Bueno! Now, I should be able to identify electron configurations. as being excited or ground and understand how this bright line series is created. It's created when I give a certain amount of energy to kick my electron up. Now he's excited, right? And then that same amount of energy is going to come off when he falls back down, and I'm going to give off light at a wavelength that's given based on how much energy I had to put in to get that electron up in the first place. That is going to give me my fingerprint, if you will. So, that's it for notes for the whole unit, guys. Now, to study for our test, you need to be able to do all of this stuff. Test is on Friday. See you in class. Sorry this one was so long.